Hey everyone, we're going to talk today about how to convert decimal numbers to hexadecimal. Before we do that though, I want to just briefly refresh you on binary, okay? In binary, we have several spaces, and each one of those spaces represents a bit, okay? We know that in binary it is base 2. So each one of these is going to have a 2 underneath because this will be 2 to the 0 place. Oops, that looks like a 6. Let me try that again. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and 2 to the 4th power. So if hexadecimal is really equal to 16, then we know that all of the numbers that we see here are actually going to be 16s instead of 2s. Alright, so here we have 16 to the 0 power, 16 to the 1st, to the 2nd, and to the 3rd. Now that's going to be a little bit more difficult to work with, so why don't we go ahead and convert these numbers. Alright, so what you'll notice here is that the numbers rapidly increase from 1 to 16 to 256 to 4096. So we used to have to go out 9 decimal places before we would even get somewhere like 256. So hexadecimal allows us to write bigger numbers in fewer spaces. Alright, so this is going to be our first example. We are going to convert 74, which is a decimal number, to hexadecimal. Okay, so what we're going to do first and foremost is take a look at all of these places, like the place values. We know that we're not going to be using 4096. That's larger than 74. We're also not going to be using 256 because it's larger than 4. So the number that we're going to be using that we'll try to put into 74 is 16. So what you're actually going to have to do is you're going to have to do 74 divided by 16. Okay? So 74 divided by 16 is going to be 4. Now usually if you type that in your calculator it's going to be 4.6. What we actually have to do here is find our remainder. So we're going back to our elementary school days. So 16 times 4 is 64. So when I subtract this, I'm left over with a remainder of 10. Okay? So the 4 that we have here is actually going to go in the second place, right above 16 to the 1st power. Now, we are left over with a remainder of 10. So we're looking at the ones place right now. Now, usually we would just write the number in the place, okay? The only difference here, though, is that 10 is technically a 2-digit number. So what we're going to do is we're going to denote 10 to be A, and this is where the letters come into place. So 11 would be B, 12 would be C, 13 would be D, 14 E, and 15 would be F. Now, the reason why there's not 16 is, remember, we count 0 to 15, and then the 16th place is the next place value. So instead of writing 10, we are going to write A. So the number 74 in hexadecimal will be 4A. Alright, the next number that we're going to do is 680. Alright, so the number we have here being 680, we take a look at our place values. 4096 is larger than 680, so we're not going to use that. The first place value we're going to use is 256. So 256 goes into 680 how many times? It'll go in twice. Now, 256 times 2 is going to be your 512. So let's subtract 680 from 512. And I get 168. Now, 168, well, first I should take this 2 and put it over here in the 256 place value. Alright, so we had a remainder of 168. Now 168, I can divide 16 into 168. So 168 divided by 16 is going to give me 10. So 10 times 16 is 160, which means that my remainder here is 8. So remember, we don't actually put a 10 here. What do we put? We actually put A. Two decimal numbers are assigned a letter in hexadecimal so that we don't get confused as to whether or not that 0 belongs in one place or the other. Alright, so if my remainder is 8, okay, 1 goes into 8 times with a remainder of 0. The remainder of 0 is what we want to see. So I put an 8 in the 1's place. So 680, oops, try that again. 680 is going to be equal to 2A8 in hexadecimal. So that looks really, really strange, but you get the idea. Alright, so one last example. Let's do 891. Now 4096 is too large. It is larger than 891, so we will not use that place value. However, we can use 256. So how many times does 256 go into 891? Okay, so the answer for that is 3. Now 3 times 256 is 768. So now we have to do some subtraction to find our remainder. So 891 minus 768 is going to be 123. We had a remainder of 123. So this 3 right here is going to go over into the place value of 256. Now 123, I can divide 16 into that 7 times. So 16 times 7 is 112. So by doing some subtraction here, I get 11. So I have 7 with a remainder of 11. So 7 belongs in the 16 to the first place value. Now 1 goes into 11 times with a remainder of 0. That's what we want to see. So we're going to put 11 in the 1's place. Now, remember, with hexadecimal, anytime I have a 2-digit number like 10, 11, 12, 13, 14, or 15, I need to reassign it a letter value. So instead of having 11, we are now going to have the letter B. So 891 is equal to 37B in hexadecimal. Alright, well that's it for now. I hope you enjoyed the video.